Thanks for joining me this morning. Welcome and good morning. As Paul mentioned, I'm going to talk about Greenness visibility analysis using Viewshed. This is a pilot study when we submitted the work. So this is our ongoing progress. This is part of my PhD. My supervisor is Dr. Jonny, Huck, and Sarah Lindley. So we're working on this project. So the work being moved from a pilot to a further stage. So I'm going to discuss some updated results too. So why greenness visibility? The connection between human health and natural environment is now widely recognized. So there is like different pathways where nature exposure or exposure to green and blue spaces can help by such as like improving air quality, heat reduction, or stress reduction. So there are some functional ways or pathways yeah, this exposure can help. In particular, we're interested in the psychological mechanism, this particular paper. So we're looking at stress reduction or mental disorder. So these are the benefits you can have through different kind of exposure to greenness. So what kind of exposure is currently is there? So this is our we did a systematic review of this of the literature, and basically we found like three objective approaches are currently there. So it's availability, accessibility, and visibility. So availability is usually how much is there, what's the average value from a top-down perspective. So it's usually measured using satellite images. And also this is like most studies approach in existing literature, where the accessibility is how far you are or how many green spaces can you access. Again, this is a more like a calculation from a top-down perspective. But the visibility is basically how much you can see or what you can see in terms of surrounding in your house or where you're traveling. So this is calculated in a three-dimensional space, X, Y, Z, because human looking at in a vertical dimension and permitting more representative measure of human experience of greenness. But again, this is one of the least studied method and a least studied approach in existing literature. The reason is the methodological challenges is there currently. So I'm going to briefly introduce few methodologies that have been practiced and what are their challenges. So the first one, the traditionally environmental psychologists, psychologists use this kind of photographs. So the pictures of different built environment show it to participant and say measure their responses and also ask questions about do they see the greenery from their window and stuff like that. But the challenges is basically these are not having any spatial context. So you do not know exactly where these are and how this varies with people moving in space. Time consuming and resource intensive for large studies, so usually not been done. And questionnaire responses again are often subjective to responders. Sometimes they have their own preferences of saying what they can see and what they don't see. So these are the challenges. Then come like straight view images. This become more popular because it has a component of geolocated straight view images, such as Google Street View or Baidu Street View in China. Coupling with artificial intelligence method, this is or image segmentation method. This is becoming more common in literature. So there's a green view index calculation that extract the number of green pixels, as you can see from here, and divide the total cells in that image to get an index value of it, how much green you can see. The challenges with this approach is basically the main challenge is basically lots of places where there's no street view images, also such as like backyard garden, community parks, and people just don't walk on the street. So you have different visibility in different locations. So this is kind of underrepresentation of visible greenness if you take account of like locations such as a backyard. And then these images are also vulnerable to distortion due to fisheye effect because these are wide angle cameras. So there's distortion and like how many pixels depending on where the object is from the camera and the projection system they're using. Lack of clarity is another issue in detecting objects at a distance threshold. There are a few studies indicating this limitation. And also we have privacy concerns. And then we come to the third point is the viewshed analysis, which is basically most popular method in the field of GIS in analyzing visibility. It's been there for long, but unfortunately, it has not been practiced too much in the green space visibility or greenness visibility analysis. So it uses DSM and DTM or the digital elevation model, and then calculate the viewshed algorithm to see like how much green you can see and what place you can see this. The usual challenges these studies have is basically low resolution of the input data, a limited number of observer points. People are often taking like one observer point in neighborhood centroid and say, okay, how much you can see. Again, this single observer points unable to capture the overall greenness in the entire spatial unit. So yeah, you're again underrepresenting this approach. It's computational resource intensive if you don't have optimization in your algorithm. So that's another issue. On this problems and these premises, we come up with our objectives of this paper. We say like, okay, what you can like explore how greenness visibility can be measured effectively using Viewshed. So this is our GIS approach, and come up with an index that can be used at high resolution, large number of observer location. We present this study for a small study in Manchester, but we then scale it up currently for whole of Greater Manchester. I will discuss this in a few minutes. And then finally, we compare it with the Google Street View images-based index to see how well there are agreement or disagreement with these two methods. So first with the input data. The input data is basically our land cover map, which is basically for green and no green data. And then we have the DSM and DTM. So the DSM is for our basically looking through the 3D environment or the obstacles there. And we collected this data, DSM and DTM, from LIDAR, this environmental agency's data. And the land cover data is quite high resolution. It's collected from Dennis et al. 2018. So how our visibility model works, so you have this input and different inputs. So we reclassify the land use data into green and no green to see like what are the green are there. And then the observer is always on the DTM, taking account of the topography and looking through the DSM and the line of sight of, so we used line of sight algorithm with a distance decay weighting function. I will discuss this far more in the next slide. So you can see like when the line of sight interact with the objects, and some part of the objects are visible or some part are not, and then we see what are the visible section, what are the invisible section, and then come up with a map with this one. So that gives a 0 and 1 value, what are the visibility level there. So how do we implement? This is the GIS part, or basically we did it for in a Python. So the Greenness Visibility Index code, you can find it in GitHub. I co-wrote this code with Dr. Jonny Huck. So we used the midpoint circle algorithm to divide from observer points. We decide like how far people should see. So we used like 800-meter viewing distance. This is coming from literature. What are the deep viewing distance there should be for an urban environment. And then we used raycasting algorithm for the line of sight and for a fixed observer height of 1.7 meter. So the raycasting algorithm is something like you casted all of it and identify a binary aspect, like how far you can see or what you can see, or if you can see the cell or not see the cell. But this binary approach is again limited. So we think like, yeah, we need to take account for like people just don't see and not see. There is a visual importance of decay of these objects, how far these are. So we used a function to express this decay weights. That's come again from two major empirical studies, and we developed this decay function with different distance. You have different weights. So combining this line of sight algorithm and the decay function, we come up with this number to calculate the greenness visibility index, where you have decay weight multiplied with the binary surface and get the value for GVI, or the greenness visibility index as we call. So what we did? So when we did this submitted this paper, it was in pilot research, but now we're showing it for bigger study areas. So we implemented this for all of Greater Manchester, about 86 million observer locations at 5-meter resolution. So at each 5 meter, we know exactly how much green you can see. And if you look, this is our map, output map. This is just produce a very high resolution output of greenness visibility. And then we compared it with the DSM and DTM, and you see there are some interesting pattern there. So before that, so each of these Viewshed calculation takes about 0.8 seconds. But as we're implementing for like 86 million observer location, we needed like high performance computing, and we implemented this in HPC of University of Manchester. So to perform this task, we subdivided the area in 65 equal subset optimized based on number of subset we need, then subdivided this subset into 16 regions for parallel processing. So about 1,040 processing in total was going in parallel. And then basically we took around 11 days to produce this 86 million based observer location. But if you do it for a smaller area, it just takes a few hours to do it. But this is a part of my PhD, so that required for whole of Manchester. So when we compared with the binary surface, we see there was a visual comparison, and you can see there is a pattern where there is green, there's more visible green. So it's obvious, but when we do a closer observation, we see no, it's just presence of greenness is not adequate. There are some places where the buildings obstructed the visibility. This is crucial for visibility. So in the next slide, I'm going to show why this is. So we created a virtual environment for a test area and plotted this visibility using other data sources like Ordnance Survey building data and the DTM is there already. So let me show what exactly, how important the buildings and how important this measurement. So you can see the green areas where at every 5 meters, you see where there's green, you see more green. But areas like this where you have green on the backyard, but you can't see from the streets because this has been blocked by the presence of building. The DSM already take this into account. So that's why you have a different level of visibility and different, even in a very close space. So this is really important because this kind of map shows the importance of visibility in doing 3D in a human perception. So this is what reflects the reality. And we say buildings are really important in taking account of visibility calculation. And finally, this is also an important aspect for the street view based analysis, because the lots of samples are taken on the streets, but it does undermine the greenness visibility on your backyard. And definitely you might have a different view when you are in a garden or community park, and a lot of people don't just spend time on the streets. So this kind of a nuanced mapping is really important to get the comprehensive measurement of greenness visibility. So as I mentioned, this is really interesting way of presenting this greenness visibility mapping. And again, street view or street level greenness often underestimate or often misrepresent the whole picture of the greenness visibility. So, but we need to compare it for some places. So we did a comparison for sample places. And when we compared with Google Street View images, our virtual environment shows our greenness visibility calculation do really reflect reality. So in places where there's no green, you can see our model also there's no green or not visible green. And in places where Street View saying is loss of green, and we also seeing loss of visible green in the calculation. So that's the model like evaluation type. So when we do a correlation between sample points and beside Google Street View and our Viewshed calculation, we found a strong positive correlation, significant obviously. And the thing is, you can see there's really good correlation between these two methods. So we complement in a way to the other existing method. So the discussion point, what we're doing and how these are helpful. So our new model is basically have several implications. So we did methodological improvement. So if you remember the challenges I mentioned, so it provides the spatial context and visibility of greenness and basically variability of greenness exposure. So you can see in a different location, you have different greenness visibility. Improves upon single observer view shed. So we're doing it very high resolution, like 86 million observer points. You can do exactly a very detailed level of measurement. Complements the Street View greenness visibility metric, but we improve on that basically by saying, okay, where the Street View images are unavailable, we can say how much green still you can see there. Simpler than artificial intelligence algorithm and less resource intensive. Yeah, but again, there is a computational power that's needed because we are trying to do for bigger areas. There is no privacy issues. It's just a 3D data and highly transferable. It can be applied in any places where you have a DSM, DTM, and land use data. So implication being can be used for large-scale socio-ecological studies to say how greenness exposure or visual exposure impact mental health or the general health. And local authority can use this kind of maps to decide where they want to invest in terms of increasing visibility of greenness. And then you can also evaluate like before and after scenario, like if you remove trees or increase greenness or redevelopment, something you'd have a better idea. What are the limitation and future development? We model the visibility combining different greenness types, all the greenness types like tree, grass are combined, but definitely people want to say like, what are the greenness visibility of trees or grass? You can do this with this model, you just need a different binary surface. We did not consider self-obscuring nature of vegetation, which is often overestimate this one, but our DSM has like winter season, so we don't think that's maybe there's not much of overestimation, but this can be incorporated in other model. And finally, greenness visibility does not indicate accessibility to green space. So we might need a combined measurement to have an overall comprehensive measurement of green space or greenness exposure. So that's being said, thank you. And any question? Enjoy the forest therapy.
Thank you, Labib. Very interesting question and very interesting report and presentation. Really fascinating. There are already questions coming in.
Yes.
The first one is from Nick Tate. Could you identify optimal paths to maximize greenness, perhaps to assess individual exposures?
Yeah. We are looking at that too, because the thing is, as we map this kind of whole city areas, if you have other data sets like individual level data, well, like GPS tracks or spatial guiding, you definitely can have this kind of detailed personal experience of or measurement of greenness exposure. Yeah, we definitely are looking at those kind of aspect of this outputs or this kind of models that we can do. Yeah.
Okay, thanks, Labib. Next one is from Joe Taylor. Thanks, this was super. Could you compare these results with a GeoParse corpus of creative literary writing set in the same area, looking, for example, for green topics and keywords? Thinking of this account.
Sorry, I didn't get the whole question again. Can you just tell me what?
Yeah, actually, it's quite a long question. I just finished reading it. Thinking of this would account for other types of experience as well as visibility.
Okay, yeah, the thing is, this is an objective measurement approach. So you can do this for other kind of experiences too. Maybe some historic references, what was there, and then you can integrate those kind of experience in this kind of nature-based like it can go for like memory thing, like did you have a different feeling for these areas? That goes a different aspect of it. Yeah, but definitely if you want to integrate, there are some ways to integrate this kind of objective and subjective experiences together. Yes.
Okay, thank you. Another question from Duncan Wyatt. Is your method biased in any way to tall features, particularly tree features, for example?
Actually, it depends. Like, yeah, if the DSM is not looking at those kind of like if it's not obstructing, you might have some biasness in estimation. But yeah, as we are not processing the DSM or the DTM, we can't say it for sure exactly how much biasness is there. But it is possible there is some biasness in the estimation depending on the height of the observer or the objects we are looking at. Yes, it's possible.
Okay. Phil is asking a question. Great work. Have you considered modeling views between DSM and DTM where the vegetation layer can identify trees? As the DSM and DTM are 2.5D, but in real life you can see under canopy layers. For example, maybe a large grassy park visible underneath a row of trees at the boundaries.
Yeah, this is really where we are still trying to figure it out. The thing is, yeah, there might be some part of the human experience people see like below the canopy, but the models is coming from a 2D layer from the from land use data. So you can see we might not have picked those kind of differences. So it is possible, like the land use data classified it for the bigger trees or canopies, so that it might have missed those nuance differences. But that's an interesting point. We definitely can do some sort of like DSM and DTM and see how they are different. And yeah, I think we should have thinking about this. I will give a thought about this. Yes. Thank you.
Okay. Paul Brindley from University of Sheffield is asking, really interesting work and similar to some unpublished work I did, this says Paul, a few years ago. So really glad to see this being worked on. There's a clear current research gap. 5 meters quite coarse for urban visibility analysis. Do you have a feel for the impact of computation time if resolution 2 meters in 5, for example?
Oh, so yes, this is a decision we made based on the balance between computational resources, basically for this bigger level of modeling. But the DSM we have is around 2 meter resolution. We could do that. But the literature we were looking at, some study says, yeah, that for bigger areas, like Wing et al. 2019 paper is there. They're saying they are being the building ages or building structure are quite okay with the 5 meter DSM. But I would definitely agree with you on that. Basically, if we have more high resolution DSM, the more nuanced differences we would find from this kind of analysis. And yeah, if we do it for smaller areas, to be personal, I would definitely go for high resolution, even might less than 1 meter resolution to model it at a proper level. But as we said, like this is 86 million observable locations. We made a choice to balance the accuracy and the time, both of them together. So that's what we did.
Okay, thank you. Duncan Wyatt asking another series of questions. First one is comparison against Google Street View. Is it fair, given that you earlier said you have a bias against Google Street View data?
The thing is, we want to show like how it is compatible with the existing methodology. Yeah, we are saying not saying any of this is basically absolute measurement of it. So we are just comparing both of these methods. But again, as you mentioned, Street View has some biases in the computation on analysis. So it's just a similar pattern of looking at the problem. And basically, we're looking at how visibility is computable and among methods. We're not saying Street View is the best approach anywhere. So there are lots of improvement you can do in both methods. So it's a work in progress. We need to do a further development on that.
Yeah. Okay, interesting. Another question from Duncan. Any surprising outcomes? These are actually the most interesting questions.
Sorry, I didn't get it.
Results very often. Are there any surprising outcomes in your work? Something you are surprised to see in your work you didn't expect to see?
The thing is, we were looking at the distance decay effect, and the surprising part was there's important influence compared to the binary visibility that we did. So we're not surprised, but computation, yeah, it's somewhat surprising to me because I was doing this two evaluation of this binary and non-binary approach, the distance decay approach, and that's really important. And I found it fascinating to see how distance decay can impact the visibility calculation overall. So that was surprising for me, and yeah, that's a different thing.
Okay, yeah. Last question from me, actually. Just out of curiosity, I'm not so familiar with Manchester, but from a just purely anecdotal perspective, do you see any correlation between Greenness index, for example, and house prices, or Greenness index and crime rates and these kind of things?
Yeah, that's another part of my PhD. So we are looking at all of these indicators together. So in general, if you look at the high like deprivation index we're looking at, so the Greenness visibility is basically very high in areas where there's no deprivation. So you can see those high, basically high-rise residential areas where the property prices are usually high. They are also very greeny. So there is some correlation going on inside this kind of different areas in Manchester. We're looking into this, and I hope that kind of work will be published. If we can publish, yeah, you'll find something interesting there.
So there's another question from Duncan Wyatt. I didn't have a chance to ask this because of time, but he was asking any practical outcomes, for example, community greening, You mentioned this slightly in your talk, I seem to remember. Maybe you can expand on this a little bit. Are you working with local councils, for example? Are they interested in your work?
Not right now, but we're planning to develop a web-based dissemination of this output so that people can search and basically look at what are the community greenness is there, or if lots of local authorities can check and say if how they can improve their
Okay,
community greenness. I think
right,
yeah.
okay.
So that's my response, but I guess
Yeah.